Welcome to section 2.3, Solving Right Triangles. There are two objectives for this section. We are going to first look at objective A, identify significant digits for a given number. In this section, we will use definition number 2 for trigonometric functions of an acute angle, along with tables or calculators to find the missing parts of right triangles. However, before we begin solving problems, it is important to understand significant digits as they determine the precision of our calculations. The number of significant digits, or significant figures as they are sometimes called, in a number is determined by counting the digits from left to right, starting with the first non-zero digit on the left. Here are some key rules to keep in mind. Non-zero digits are 1 through 9 are always significant. For example, 423 has 3 significant digits. Leading zeros, or zeros before the first non-zero digit, are not significant. For example, 0.0043 has 2 significant digits, 4 and 3. So the 3 zeros before the 4 are not significant. Trailing zeros, or zeros at the end of a number, are only significant if there is a decimal point. So for example, 1,200 has only 2 significant digits because there is no decimal point. However, 1,200.0 has 5 significant digits because there is a decimal point. The relationship between the accuracy of the sides of a triangle and the accuracy of the angles in the same triangle is shown in the following table. So our first column here is accuracy of sides, second column is accuracy of angles. Okay, so 2 significant digits for the sides of our triangle, then we're going to round our angles to the nearest degree. If there are 3 significant digits to the sides of our triangles, we're going to round our angles to the nearest 10 minutes or 1/10 of a degree. Then for 4 significant digits, we will round our angle to the nearest minute or 100th of a degree. So understanding significant digits is crucial when using trigonometric functions because it ensures that our answers are as precise as the given values. In this section, we will apply these rules while solving problems involving right triangles. Here is our first example. Give the number of significant digits on the side given in the following triangle. So we have a triangle here, and the base of this triangle has a side of 16.03. Okay, so 16.03 is the side of our triangle, and 16.03, all right, has no leading zeros or trailing zeros. So we're going to count the number of digits going from left to right. So that would be 1, 2, 3, and 4. So this value would have 4 significant digits. Okay, let's do the next one. For the given triangle, round the number in parentheses so that its accuracy corresponds to the accuracy of the other numbers in the triangle. Okay, so we have a triangle here. The hypotenuse of our triangle is 12.6, and the angle measure of one of our angles in our triangle is 35.4 degrees. 12.6 has 3 significant digits. 35.4 has 3 significant digits. So our side here, that's 10.2706, must be rounded to the tens place so that it as well will only have 3 significant digits. So we're going to round this to 10.3. Okay. All right. We can now head into our second objective, B, that says solve right triangles using definition 2 for trigonometric functions. Now that we've established definition 2 for trigonometric functions, we can apply it to solving right triangles. This means using the given information, whether it's side lengths or angle measures, to determine all the missing sides and angles. By leveraging the trigonometric ratios and a calculator, we can systematically solve right triangles and apply these techniques to real-world problems. Exercise 3. Triangle ABC is a right triangle with C equals 90 degrees if A equals 50 degrees and lowercase c equals 14 centimeters. Find lowercase a, lowercase b, and b. So the first thing that I know here is I know I'm dealing with a triangle, and not just any type of triangle. I'm dealing with a right triangle. So I'm going to draw a right triangle, and I know right triangles have a 90-degree angle. Now in this specific triangle, it says that C is the 90-degree angle, and my triangle is called ABC. Okay. I also know that angle A is 50 degrees, and I know lowercase c is 14. Now the lowercase letters we know represent the sides of our triangle, and the uppercase letters represent the angles. So lowercase c would be across from my angle C, so that would be the hypotenuse. Okay, and then I am told that I need to find lowercase a, lowercase b, and angle B. So A, B, and B. So I need to find all of these missing sides and angle. So let's first find angle B. I know angle B is one of the 3 angles. I know that my right angle here is 90, and I also know that the total angles within the triangle equal 180 degrees. So that means if I were to add angle A and angle B together, they would have to equal 90, so that the total equals 180. So B will equal 90 minus A. Well, I know that A is 50, and 90 minus 50 is 40. So I know B equals 40 degrees. Okay. All right. Now we can find our sides. Okay. Lowercase a and lowercase b. So let's find A. So in finding A, we can use one of the trig functions to help us. So a nice acronym to help us solve these is the acronym SO, CA, TO, where SO goes with sine, CA goes with cosine, and TOA goes with tangent. So sine is going to be the opposite over the hypotenuse. That's where you get SOA. Cosine would be the opposite over the hypotenuse, and TOA would be the opposite over the adjacent. So if I'm looking at the measurement for A, and I know the angle for A, and I know the hypotenuse, I'm going to use one of the trig functions that contains the hypotenuse, which will either be sine or cosine. But since A is opposite my angle measure A, I am going to use sine. Sine of A would be the opposite, so that would be A over the hypotenuse, which would be C. Okay, so if I want to find A, I would have to multiply my sine of A times C, and now I can substitute what I know. So C here is my hypotenuse, which is 14, and then A is 50. So when I plug this into my calculator, I should get a pretty long answer. Wait, 72462. All right. But now I want to make sure I round to the correct significant digits. Since my angle and my sines are two significant digits, I need to round this to two significant digits. So A will equal 11 point, actually no, just 11. If I add a decimal, then I add another significant digit. So just 11 centimeters. Okay. All right, so we have angle B and we have side A. So now let's find side B. So side B is the adjacent side to my angle A. So adjacent and hypotenuse is what I'll be using. So that would be cosine. So cosine of A is going to equal B over C. So B will equal C times the cosine of A. I know C is 14, and I know the angle measure of A is 50. So when I enter that into my calculator, I'll get this decimal. I need to round this to two significant digits. So this would be 9.0 centimeters. Okay, so we have found the angle B, we found the sides B and A. So B equals 9.0. Awesome. All right, next exercise here. We have triangle ABC is a right triangle with C equaling 90 degrees. If A equals 3.54 and B equals 5.12, find the remaining side angles. So we are going to first start with our right triangle. We know that C is the right angle. So our other angles here, A, B, C, for other vertices. We know that the side, lowercase a, is 3.54, and the side B is 5.12. And we're asked to find the remaining sides and angles. So that means we need to find the hypotenuse, angle A, and angle B. We can use our acronym. So, COA to help us find these missing side and angle. So we know, well, let's first start off with angle A. So from angle A, we know that its opposite side is 3.54 and it's adjacent to 5.12. So the trig function that can help us solve that is the tangent because it deals with the opposite and the adjacent side. So the tan of A will equal lowercase a over b. So if I wanted to find angle A, I would take the inverse of tan A over B. Now I know what A is, which is 3.54, and I know what B is, which is 5.12. So entering that into my calculator, all right, I'm going to get 3.7 degrees. I want to round to 3 significant digits. Okay, so I know the measurement of angle A, so I can find the measurement of angle B by doing something very similar to what I just did, or I can take the measurement of A and subtract it from 90 because I know A and B must equal 90 degrees in order for all the angles in my triangle to equal 180 degrees. Okay, so to find B, I'm going to take 90 minus A, so that would be 90 minus 34.7, and I'm going to get B, which equals 55.3 degrees. Again, we want to make sure it has 3 significant digits because my sides also have 3 significant digits. All right, so I found the measurement of angle B, found the measurement of angle A. Now I need to find the side of C. And there are more than one method to finding C. You could use the Pythagorean theorem, or you could use one of the other trig functions. And in this scenario, I'm going to use one of the trig functions. So I'm just going to look from the perspective of A. You can look from the perspective of B if you would like. From the perspective of A, knowing that A is 34.7 degrees, and I'm trying to find C, C is the hypotenuse, and I can either use the adjacent side or the opposite side from A, angle A, to help me find it. I'm going to use the opposite side, so the sine of angle A will be the opposite over the hypotenuse. The hypotenuse, C, then will equal A over the sine of angle A. So the side of A I know is 3.54, and the angle measurement A is 34.7. So C, when I plug this all into my calculator, will be this long decimal value. But I want to round it to 3 significant digits, so I'll get 6.22. Okay, and so we've now found the angle A, the angle B, and the side C. Awesome. Okay, exercise 5. The center of the circle is at C. If the radius is 35 meters and angle A is 28 degrees, find Y, then find X. So we have a circle here that's in red. The center is C, all right? And we are told that R is 35 meters. So wherever I see R in this image, it's going to equal 35. Angle A, which we know is right here, is 28 degrees. We need to find Y and then find X. Okay? So just to review, anywhere where I see R, it represents the radius, which is 35. I know angle A is 28 degrees. I need to find Y, and then I need to find X. Okay? All right, so let's do that. I'm going to make some more space here. Okay, so let's draw one of these triangles that we're working with. Since I know my angle A, I'm going to draw the left-hand triangle. So let's draw that out. Okay, so I have A here, and then I'm just going to make my vertices. So this is X, R, R, and Y. And this is F and C. Okay, now let's label this. So I know A is 28 degrees. I know R is 35. So both of these are 35. And I am first asked to find Y. Okay? So using what we know, Pythagorean theorem, trig functions, the total sum of angles in a triangle, all the things that we know, what can we use to help us find Y? Well, I know my angle is 28. I know its opposite side is 35, and I'm trying to find its adjacent side. Well, what trig function can I use to help me? And that would be tangent, because the tan of A would be the opposite over the adjacent, which is Y. Well, I'm trying to find Y. So to get Y by itself, I would multiply both sides by Y, and then I would divide both sides by the tan of A. That's how I would get Y by itself. Well, I know R is 35, and I know the angle of A is 28. So plugging that into my calculator, I'll get 65.825426. Okay. Since my angle and my sides are both two significant digits, I'm going to round Y to two significant digits, which would be 66 meters for my units. Okay, so we've just found Y. So we know now the length of Y is 66 meters. So now that I've found Y, let's find X. Okay. So now we want to find X. So let's adjust our triangle now to what we know. So we have our triangle here. Okay, let me make this line a little shorter. There we go. This is A, F, C, X. Okay, we know that this is 66. We know that this is 28. We know that this is 35. We know that this is 35. Okay. And we know that this is a right angle. Alrighty. And we need to find x. So, to find x, we need to first note that x is a part of the hypotenuse of our triangle. Okay. So this whole measurement here represents c, lowercase c. Or in this case, let's stick with our letters so we don't get confused. This would be lowercase f because it's opposite angle f, but it's the hypotenuse of our triangle. Okay. 66 would be a leg, and 35 would also be a leg. So if we know two legs and we're trying to find the hypotenuse, we can use the Pythagorean theorem, a squared plus b squared equals c squared, to help us find x. So a here, let's just match the a since we have another a, would be 35. B here is the other leg, so that would be C, which would be 66. And C is our hypotenuse, which in this case is F, so that would be x plus 35 squared. And so now we can solve this linear equation to help us find x. So 35 squared is 1,225. 66 squared is 4,356. We're going to leave the expression x plus 35 squared as is for now. I'm going to combine my two terms on the left-hand side to get 5,581. Okay. Now I want to get rid of the square on the right hand side. So to do that, I'm going to take the square root of both sides. So now I have x plus 35 equals the square root of 5,581. To get x by itself, I'm going to subtract 35 to both sides. So I have the square root of 5,581 minus 35. I'll put this whole expression in my calculator and I should get 39.70609. Since my sides and my angles are all two significant digits, I'm going to round x to two significant digits, which would be 40 meters as my final answer. Okay, awesome. I enjoyed that problem. Did you? All right, let's do the next one. Exercise 6. A man is walking away from a 25-foot flagpole. At point B, the angle to the top of the flagpole is 57 degrees. At point C, the angle to the top of the flagpole is 43 degrees. Find his distance from the flagpole at point B and at point C, round to the nearest tenth. Okay, so it's telling us what to round to. So we have our flagpole here. We know that it's 25 feet. What else do we know? At point B, the angle to the top of the flagpole is 57. So we know that this is 57 degrees. And then at point C, we know it is 43 degrees. Okay. we need to find his distance from the flagpole at point B and at point C. Okay, so it's already labeled here for the distance for point B as X. And then we also need to find the distance from point C. So let's label that Y. Okay, so we need to find X and we need to find Y. All right, so let's first find X. So just to give us more space here, I am going to draw out our triangle. We're going to find X first in this one. So we have our triangle here. We have our right triangle. This vertex is D, A, and this one is B. We want to find X. We know the flagpole is from A to D, and that's 25. And the angle measure of B is 57 degrees. Okay, so we have an angle measurement. We have the side measurement opposite it, and we're trying to find adjacent. So opposite and adjacent would be tangent. So the tan of B will equal lowercase b over x. So x would equal b over the tan of angle B. So that would be 25 over the tangent of 57, which would equal 16.23518. We're asked to round to the nearest tenth, so x would equal 16.2 feet. All right, and this is the distance from the flagpole at point B. So this is from point B. Okay, so now we know what x equals. So let's find our y. So we identified y as the distance from C to D. So the distance from the flagpole to point C. So if we were to draw that triangle out, we got a right triangle here, D, A, this is C. We know the angle is 43 degrees, okay? And we know the flagpole is 25, and we now want to find y. So B is in here, but we want this whole distance, and that's y, okay? So we can use the similar process that we used to find x to find y, because we know our angle, we know its opposite side is 25, and we're trying to find its adjacent. So the tan of C is going to be lowercase c over y. So y will equal lowercase c over the tan of angle C. So y will equal 25 over the tan of 43. So this would equal 26.80921. So y will equal 26.8 feet. And this is the distance from point C to the flagpole. Again, we rounded to the tenths place because our problem asked us to. All right.